Now, I want to show you this picture. This is the Hubble Ultra Deep Field. So it's a picture taken of a tiny, tiny, tiny square of what looked like completely black sky. And so this telescope trained a camera on it for a really long period of time to get all of the light from that little black square, and this is the picture that we got. So this is 0.000024% of the sky, so a tiny, tiny area of the sky as we look up. And in this single picture, if we look at the, take the light from a little area of sky for long enough, we'll see that that is 10,000 galaxies, not stars, galaxies in that tiny, tiny bit of sky. Now, the Milky Way galaxy, that's what we're part of, that's got hundreds of billions of stars. Here's another picture of a galaxy. So there were 10,000 galaxies, just like the Milky Way, in a tiny, tiny bit of sky. So you can imagine if you extrapolate that to all of the sky, there are, again, hundreds of billions of galaxies in our universe. Each galaxy has hundreds of billions of stars, and in fact, in recent decades or years, we've been looking at stars and we've been finding that lots, like heaps and heaps of stars all have planets. And so if we think that most of the stars we look at, we end up finding, yeah, well, they've got at least one planet, often more than one. And we know that there's hundreds of billions of stars in each galaxy. And we know that by looking at this teeny bit of sky, that the universe is chock full of galaxies, hundreds of billions of galaxies, that there are just trillions and trillions of stars. And it's really interesting to think about the fact that we're near one star, the sun. We're on only one of the planets of our star. And on this planet, there are millions of forms of life. And so what we've found is that our planet, Earth, is in just this really, really great spot. We call it the Goldilocks zone for life. And it's basically because we are close enough to our star for liquid water to exist, not so close that it's boiling hot and water all evaporates, and we're not too far away that it's just ice and solid and no liquid water. So I've got liquid water all in my body, and that's a massive, water's a massive part of life. And so there's this Goldilocks zone of stars, and it's also called the Habitable Zone. So here I've got if I've got a really hot star, you would see that there's an area around it which is way too hot for life, we think. There's this green zone, a terrific zone here, which is the Goldilocks zone, the Habitable Zone, which is where liquid water can exist. But then outside that, it gets a little bit too cold, and we don't think life can exist there. A star like our sun, or a planet like Earth, is probably around about here, maybe. But a sun-like star is not too hot, but again, it's got an area which is too hot around the sun. It's got an area which is just right, the habitable zone, the Goldilocks zone, and then of course it's got an area which is too cold as well. And you can even cooler stars can also have a habitable or Goldilocks zone where there is liquid water. And so this is looking at the different states of water. We know that water on Earth is required for life to exist. All life on Earth, uses water in some way. And so when we're looking at the trillions of planets as we search for alien life, we are looking most particularly at planets which we think are in that habitable zone around their star. So it's not too hot for liquid water to be there, not too cold for liquid water to be there either. But that's, I suppose, again, our search, our understanding of matter and chemistry is enabling us to find out enormously great things about our entire universe.